Hello and welcome to part 11 of chapter 6 Triangles. We were solving riders. First, we solved 8 riders based on Pythagoras theorem, and in the last video, we solved 4 riders based on BPT and similarity. The fifth one was given for the homework. Let's go through the homework first. This is a question, and we'll read the question along with the figure. If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to triangle PQR. The triangles are similar is given. What is asked to prove? AB into PM is equal to AD into PQ. Now for the first time we are asked about the product of sides, two sides on the left hand side and two sides on the right hand side. What is done here is just one step extra. When you prove the two ratios are equal, cross multiply, you will get this answer. Now look at the sides involved here. AB, PM, AD and PQ. So it is very clear which triangles to consider. The triangles are ADB or ABD and triangle APQM. Let us consider the two triangles ABD, ABD and here PQM. Since the triangles are similar, that is ABC and PQR, we can write AB upon PQ is equal to BC upon QR. But the triangles which we have considered, in that triangle BC and QR is not there. So what we'll do is, in place of BC, we'll write 2 times BD, and in place of QR, we'll write 2 times QM, because D and EM are the midpoints, because AD and PM are the medians. So 2 gets cancelled, and you get AD upon PQ, AB upon PQ is equal to BD upon QM. Now we need an included angle. And here comes the included angle. Angle B is equal to angle Q, because again the reason is corresponding angles of similar triangles. And now if you look at statement 3 and statement 4, it is very clear the two triangles are similar by AS similarity criterion. For the first time we are using, prior to this we used everywhere AA similarity criterion. Yes, the two triangles are similar. And now let's go to the ratio of the corresponding sides. AB upon PQ is equal to AD upon PM. Corresponding sides of similar triangle, cross multiply. One side you will get AB into PM, other side AD into PQ, and this is asked to prove. Very simple rider. Though there are 7 marks, this will not come for 3 marks. This is again a 2 marks rider. Now what are 3 marks rider? For that we'll go to the next rider and see the 6th one. 6th onwards, all riders are from the board paper for 3 marks. So let's go to the rider number 6. We'll see the figure. Yes, PQR is a triangle in which PQ is equal to PR, and T is a point on PR such that QR square is equal to PR into TR. Okay, let's see what is asked to prove. You are asked to prove QT is equal to QR. Now here, altogether in the figure, there are 3 triangles. Now we have to select 2 and prove them similar. Then only we'll get ratio. The 2 sides are equal because the ratio is equal to 1. So how we can select the 2 triangles is, what is given to us is PQ is equal to PR. And what is asked to prove is QT is equal to QR. So second triangle, I will separate it from the main figure and it looks like this. Now you see PQ upon PR is given equal and we have to prove QT is equal to QR. So two triangles which we have to consider are triangle PQR and triangle QTR. Let's start with what is given. That is QR square is equal to PR into TR. So rearrange the terms and you get QR upon TR cross multiply is equal to PR upon QR. So look at the figure. P, that is QR upon TR here. PQ QR is down, TR is this side, and PR this side, and upon QR. Here also we need included angle. An included angle is coming, that is angle R is equal to R common angle. Included angle, and again 2 and 3 statement T, we again get SAS similarity criterion. So we got triangle PQR is similar to triangle QTR. Now we will write the ratio PQ upon QT. You can see they are corresponding sides is equal to PR upon QR. Just rearrange the terms, get PQ and PR, PQ upon PR and QT upon QR on the other side. Because PQ and PR are equal, that is given to us, so that is 1. So QT upon QR is also 1. And when the ratio is 1, we can say QT is equal to QR. This is a 3 mark rather, though there are 8 steps. The reason is here selecting the triangles and writing the correspondence correctly is little bit difficult here. Therefore, this was asked in the board exam for 3 marks. Let's go further. We'll see the rider number 7. We'll see the figure also. Angle AMT. Here is the angle AMT. Is an external angle of triangle MNT. That is this triangle M and T. Bisector of this external angle AMT and intersects NT at Q, that is MQ is the bisector. Line TR is parallel. Line TR here is parallel to MQ here, as shown in the figure. What is asked to prove? NQ upon TQ is equal to NM upon TM. Now here there is something, in one triangle there are parallel lines. So obvious we have to go for a BPT. Now in triangle NQM, where we have RT is parallel to MQ. Therefore, you will get NT upon TQ here, and you will get NR upon RM BPT. Now, at this stage, if you see what is asked to prove, except TQ, rest everything is different. In place of NT and T, we want the entire side NQ. And in place of NR, same thing, we want NM. Now this can be done if you add the denominator to the numerator. How to add denominator to the numerator? Just add +1 on both the sides, adding 1 on both sides. Then we will get NT plus TQ upon TQ is equal to NR plus RM upon RM. Now add NT plus TQ is equal to NQ upon TQ, and this side will get NM upon Rm. Now look at what is given. There is only one is left. In place of Rm, here there is Rm, we want Tm. Tm is here. Rest everything is there. Now, when this was asked, many said this is out of syllabus. I'll tell you why it was said like that, out of syllabus, and why it is not out of syllabus also I'll tell you. Now from statement 1, if you directly go to statement 3, the adding the denominators to the numerator, it comes in chapter ratio and proportion, which is not there for you, and this property is called as componendo. Again, this is not there for you. So many said this is out of syllabus. But if you add 1 on both the sides, which you are free to do it, whether add 1 or subtract 1, whatever it is. Now if you do that, you get the same result. So there is no need of using componendo here. Just add 1 on both the sides, you get that result. Therefore, this example, this rider is not out of syllabus. Okay. Now here in 4 statements, in just 4 steps, we got 90% of the proof. Now what is left is also very important. For that we will go to the figure. Yes, MQ is the angle bisector. So we have this angle is equal to this angle. Now look at angle AMQ, this angle. This angle is equal to angle MRT, this angle, because they are corresponding angles. And the second one is angle QMT, this angle, is equal to angle RTM, this angle, because they are alternate angles. Now see, this angle is equal to this angle is equal to this angle, and these two angles are equal, therefore these two angles are also equal. And from the last year's theorem, that sides opposite to equal angles are equal, you can prove that Rm is equal to Mt, and I think that is what is left. In place of Rm, we want Tm. Now how to prove it? We will see. This is what is asked to prove. This is the figure. And now, just now what I explained to you. Angle TMQ is equal to AMQ, because MQ is the angle bisector. Angle TMQ once again is equal to RTM. They are alternate angles. Angle AMQ is equal to angle MRT, because they are corresponding angles. So from these 3 statements, that is 5, 6 and 7, we get the result. Angle RTM is equal to MRT, and because of this, Rm is equal to Tm. Now go to statement 4. You can see that here now. Now there is Rm. Now look at what is asked to prove on the top. That in place of Rm, we want Tm. And in statement 9, we have proved that Rm and Tm are equal. So now from 4 and 9, we get NQ upon TQ is equal to NM upon TM. Very, very interesting rider. Oh, we'll take a time for a break, because the video is little lengthy, and second reason is the topic is also difficult. So you can pause the video and you can take a break, but in the break I will explain you what should be your approach to riders. Now first you prepare rest everything from the math syllabus of standard 10th. Once you are prepared, you are perfect, then come to riders. Oh, here we solved so far 8 from the Pythagoras theorem. Total we may solve around 17. We have to solve the riders in phases. So when you'll come to school, we'll solve more riders. Riders we have to solve throughout the year. Now when in the exam, board exam, the rider will come in question number 7. So what you do is you answer question number 8 first and then keep the 7th question last, so that at the end, whatever time you get, you can solve rider, because riders takes time. Then see, if you are finding riders very difficult, don't worry. Without riders also, in maths, you can score more than 90%, which is considered as very good score in mathematics. Now, there are subjects like maths, science, and social science, where students can score 10% marks, 100 out of 100. But if you look at the maths, so I have seen maximum 20 students scoring full marks in Goa. Minimum sometimes it is below 5, maximum it is never gone above 20. Now if we say 20 students score full marks, then out of 20,000, 20 students out of 20,000 score full marks, which is just 0.1%. So it is not only because of rider, but it is mostly because of riders. So riders are difficult, but don't give up. Practice, and as I said, keep it last, so that whatever time you get, you can use for rider. You take a break, you continue your break, but I'll continue with my video. Eighth one, again from the board paper. In the given figure, ABCD is a parallelogram. Now, riders are difficult because now parallelogram is come, and you should know the properties of parallelograms, which you have learned in standard 9th. AQ and DC are produced to E. P is a point on AD such that PQ, slightly do the correction here, PQ is parallel to DE. Again parallel. So let's go to the BPT. Now, here you will find it is not the ratio which is cross multiplied, but there are 3 sides, product of 3 sides, and the product of 3 sides on the other side. How to deal with this? First, we'll go to the PPT. Yes, consider triangle ADE. AQ upon QE is equal to AP upon PD. Cross multiply. You get AQ into PD is equal to AP into QE. Now just see what is asked to prove. In the final statement, AQ is not there. So you have to replace AQ. PD is there. AP is there. QE is there. In addition to that, AE is there. AE, that is AE is here. Then BA is there. BA is here. And DA is there. It is here. So from this, out of many triangles in this figure, you have to select 2 triangles in which there will be AQ, because you have to replace for AQ. We need AQ is here. We need AB. We need AE. And we also need DE. So more or less, it is clear which 2 triangles to consider. They are triangle ADE and triangle QBA. Now how to naming is also important. Now see, D and B angles are equal. So because they are the opposite angles of a parallelogram, and A here and E, point E, they are corresponding vertices because these two angles are equal because they are alternate angles. This is the only difficult part. So select the triangles and write the correspondence, that is ADE, then it is QBA. Let us see. Angle ADE is equal to angle QBA, opposite angles of a parallelogram. Then angle DEA is equal to angle BAQ because alternate angles. So AA similarity. Now we'll write all the three ratios corresponding sides. Now which two to select? We want to replace for AQ, so AQ is here, so the last ratio is required. We want DE and BA, which are here, so last two ratios. Yes. And now what we'll do is we'll write a statement for AQ. This is what is asked to prove. This is the figure, and yes, this is the same step I have written here for continuity. And now you can write here AQ is equal to AE into BA upon DE. Now, where to substitute AQ? Yes, this is your statement 2. AQ into PD is equal to AP into QE. So this statement, so this AQ, that is from statement 8, you put in statement 2. So you will get AE into BA upon DE into PD is equal to AP into QE. Cross multiply and see the result. AE into BA into PD is equal to DE into AP into QE. Little bit difficult, but not very difficult that you will not be able to solve. Let's go to the next one. Next one is a rider from board paper of 2020. This year's board paper. In triangle ABC, D and F are 2 points on side AC, and E is a point on side BC. Such that again here parallel is there. DE, where is the DE is here, is parallel to AB. So this will take triangle ABC, and FE is parallel to DB. So we'll take triangle BCD and we'll apply BPT. Now actually we solved I think very second example where we used BPT twice, and in just 4 steps we got done. This part is same. That time I told you that you can use this idea somewhere else. The first 4 steps are similar to question number 2. So what is asked to prove is little bit different here. DC square minus FC square is equal to FC into AF. First part is simple. In triangle ABC, when you apply BPT, you will get DC upon AD is equal to EC upon BE. BE is here. Okay. Now once again, consider triangle BCD. BCD, yes, this triangle. And apply BPT, you will get FC upon DF is equal to EC upon BE. Now naming the sides I have taken according to what is asked to prove. Well, after this, if you see the statement 1 and statement 2, you will find the right hand sides are equal, EC upon BE. So left hand sides can be written. Now this was the proof in question number 2. Only this part was asked. We increased it by writing the sides parallel and all. That is not required here because as it is, when you say BPT is understood, otherwise as it is, this is around 10 step rider and you will increase it to 12 steps. Now, uh, next step is the only important step, but once you get that step, rest everything is simple, but that is the most difficult step. Now DC, so as it is we'll keep, and in place of A D we'll write AF minus FD. Now there is a little hint here because AF is here, so we required AF. Second is in place of DF we will write DC minus FC. The reason is if you cross multiply DC, there is a hint, but that is not sufficient. You will get DC square. Let's go ahead. This is what is asked to prove. This is the figure, and yes, was the previous step. The reason is D is between A and F is between D and C. Cross multiply. DC into DC minus FC is equal to FC into AF minus FD. So DC square, what I mentioned, you are getting, and second you are getting minus DC into FC. Other side also you will get FC into AF. You can see here FC into AF is here. So FC into AF. So we will not touch that part at all. And minus FC into FD. So we'll take this minus DC into FC on the other side. So DC square is equal to, I said, FC into AF, don't touch because that is here. That is FC into AF. And this is shifted on the other side. And you can see here FC is common. Take FC common. So in the bracket you will get DC, this is total DC, minus FD. So what you get, that bracket is also FC. Yeah, FC into FC. This minus FC square from the right hand side, bring it on the left hand side. So DC square minus FC square is equal to FC into AF. The rider from this year's board paper. I will say that this is on the little difficulty side because especially the fourth statement, because the hints are very less here. But once you write the fourth step, rest is very simple. In the beginning I mentioned some steps. I said there is no need to write because as it is there are 10 steps. So with this, this topic is over. This chapter is over. Hope you enjoyed this chapter. Total 11 videos. Thank you very much.